Hey Algebra 2, today we're going to work on modeling with quadratic functions. So that's code for we're going to have some graphs and we're going to do some word problems. So the first thing we're going to do is find the solution of a quadratic equation graphically. So I have my graph here, and you need to know that solution is code for x-intercepts. Sometimes we also use the word roots of the function, and sometimes we use the word zeros of the function. These are all phrases that we tend to use interchangeably. So it touches the x-axis right down here at -2, and so I know by looking at the graph that my solution is -2. This graph crosses in two places. That means this one has two solutions. So the first solution is here at -3, and the second solution is at 1. Doesn't matter if the graph opens up or opens down, the solutions are still where the graph crosses the x-axis. This one has solutions at -2 and +2. So we're going to work on real-world problems. The main thing that you need to know on real-world problems, it is either going to say, what is the maximum height? If it says, what's the maximum height, that's code for, hey, find the vertex of the problem. Or it's going to say, when did it land? If it says, when did it land, you need to set your equation equal to 0 and solve. So you know how to solve equations by either factoring or using the quadratic formula. Either one can work. A frog is sitting on the ground and he's scared by a big dog. The frog jumps. His movement is modeled by this equation, where h is the height and t is the time. First one is, how many seconds after jumping will the frog be at his maximum height? All right, so we said maximum height is code for vertex. So we have, if we sketched a little graph here, we have x and y. So if you look at your equation, where that t is, that's usually where the x is. So x and t must be the same thing. So that means time goes on your x-axis, and that means height goes up on your y-axis. So the frog jumps up, and then he lands again. So right here is where he's at his maximum height, and that is the vertex. So we have to find the time first, and so that's the opposite of b over 2a formula. So here's my b. So a is -6, b is 6, and then you would add in c equals 0. So the opposite of 6 is -6 over 2 times -6. So I have -6 divided by -12, which reduces to a half a second. So in 1/2 of a second, that frog was at its maximum height. It says, how high does the frog jump? So we want h right here, and so we're just going to plug a half in into those two t's. And I'm also going to switch that to a decimal. So just take what you get for step 1, plug it in place of t in step 2, and put that in your calculator. And my calculator said 1.5. So how high does the frog jump? 1.5 feet in the air. How many seconds until the frog is back on the ground? So the frog starts on the ground, he jumps, he's in the air, and then when he lands, he's back on the ground again, and the ground has a height of 0. So anytime it says ground, that's when you know you're going to set your h equal to 0. So into this equation right here, I just get rid of the h and I plug 0 in. When I see this problem, I see a GCF. So when you want to solve it, you have 3 options. You can factor out a GCF, which is what we're going to do here. If you have 3 terms, you can try to factor your trinomial by making your ACB chart. Or if factoring fails you, or if the numbers are really big, you can run the quadratic formula. I'm going to factor out the GCF here because everybody has a 6 and everybody has a t. So I'm going to divide negative 6t. And whatever the sign of the first term is, that's always the sign that I factor out. So I'm going to factor out negative 6t.
Good afternoon, classes. It's that time, 2:10.
All right, we're back now. And so after you factor out a negative 6t, then we divide. So negative 6t squared divided by negative 6t equals t. And 6t divided by negative 6, so I have a positive divided by a negative, and that equals negative 1. So those terms basically cancel each other out. So once it's in factor form, I'm going to break it apart and set each factor equal to 0. So one of my equations is negative 6t equals 0, and the other is t minus 1 equals 0. If I want to solve for t, I'm going to divide both sides by negative 6, and t equals 0. And then over here, I'm going to add 1 to both sides, and t equals 1. So if you look back at the picture here, we knew he was on the ground at time 0, but then we really didn't know when he landed. And so when we got our answer of t equals 1, that is when he landed. 1 second. Let's do another one where we will have to probably use the quadratic formula. So Abby's going to toss a coin off a bridge into the lake below. The distance in feet is modeled by this equation. What is the greatest height of the coin? So anytime you see the phrase greatest height, that is generally code for find the vertex of it. So the vertex is always x comma y. But here, the x, that's where your t is. So that means that time is x and that your height is the y. So what's the greatest height? So in order to find the height, we first have to find the time. And we're going to use our negative b over 2a formula. So there's a, b, and c. So the opposite of 96 is negative 96. Your a term is negative 16. So I have negative 96 divided by negative 32. And I got 3 seconds. So in 3 seconds, the coin reached its maximum height. All right, so there's step 1. Step 2, find the height. So I'm just going to plug 3 in place of those 2 t's. Negative 16 times 3 squared plus 96 times 3 plus 112. I ran these numbers in my calculator and I got 256. All right, so what is happening with this scenario. So here's 0. Down here is time. We're going to start from 112 feet up. So we're going to toss it. It's going to go up, and then it's going to land and come down. So right here at 3 seconds is where it hurt 256 feet. So this is the maximum. Well, if that's the maximum, will the coin ever reach 300 feet? No, because we just found out that 256 was the maximum. This says, when will the coin be at a height of 200 feet? So we have to solve for t. So when will it be at 200? So in place of that h right there, I'm going to sub 200 in its spot. Plus 96t plus 112. So I have a quadratic. We learned a long time ago that we like our quadratic equation set equal to 0. So in order to do that, I'm going to subtract 200 to the other side. So 0 equals negative 16t squared plus 96t minus 88. So there's my A, my B, and my C. These numbers seem way too large to make an ACB chart, so therefore I'm going to run the quadratic formula on it. X equals negative B plus or minus square root B squared minus 4AC all over 2A. So now I'm just going to go substituting. Opposite of B, so that means a negative 96 plus or minus the square root. 96 squared minus 4. My A value is negative 16, and my C value is negative 88. All over 2 times negative 16. So I get negative 96 plus or minus. I ran the string of numbers under the radical in my calculator, and I got 3,584 over negative 32. All right, so now I have to go use my calculator. This one works pretty nicely. So here's how I type it in. Negative 96. I'm going to start with the plus. Radical 3584. And then I hit the enter button. And then I'm going to go divided by negative 32. Enter again. So I get 1 point. I'm going to round that up to 13. On this calculator, you can hit the arrow up button. And now I need to run the numbers again, except I need to use the minus. So I'm going to arrow over, and I'm going to change that add to a subtraction sign, hit enter, and then I still have to divide that by negative 32, hit enter again, and I get 4.87. So what exactly is happening here, Kathy? All right, so I'm starting up here at 112 feet because it's the same one as before. It's going to go up and it's going to come down here and land. So we decided that it hit this maximum height at 256. And down here is time. We wanted to know when it's about here at 200 feet. So I'm going to hit 200 feet on the way up. So on the way up, that's going to be at 1.13 seconds. I hit the top, and then I hit 200 feet again on the way down. So at 4.87 seconds is on the way down. So in this case, I will hit 200 feet at 2 different points in time. All right, now we have a business model. I designed a new sports bike. I'm going to make a lot of them, and I'm going to sell them for a profit. Here's my equation that models the profit made. So P is the profit, and X is the sales price that you're going to make. All right, so let's say, X is the sale price, and the Y part of it is the profit. So it says, at what price do you need to maximize the profit? So maximize profit is a vertex kind of problem. And so when you run opposite of B over 2A, you are finding the X portion. We are finding the sales price. So we're able to do that with just this formula. So opposite of B is negative 920 over 2 times negative 2. So I get 920 divided by negative 4. It's negative, by the way. And that equals $230. So a $230 sales price will maximize your profit. How much profit will I make at that price, you ask? Let's plug it in and find out. So this is your X. So in place of those two X's, I'm just going to plug in 230. Negative 2 times 230 squared plus 920 times 230 minus 84,000. So I ran these numbers in my calculator, and I got $127,140. So that would be my profit if I sold my bikes at $230. It says, at what price would you make zero profit? All right, so this big P here is my profit, and so that means if you set your equation equal to 0. At what price would you make a zero profit? All right, so here's what I envision happening. So I have a y-intercept way down here at negative 84,000. So this is my price, and up here is going to be my profit. So my graph is going to look something like this. So up here, my maximum profit is $127,000, and then right here my profit is 0. Right here in the middle is where my $230 price is. So I'm trying to figure out what would that point be. So if I charge too little, I'm going to make 0 profit. And then over here, if I charge too much, I will also make 0 profit. I decided that it was best if you just run the quadratic formula on this. So x equals negative b, so negative 920, plus or minus square root, 920 squared, minus 4 times negative 2 times negative 84,000, all over 2 times negative 2. So I have negative 920 plus or minus. I ran these numbers in my calculator and I got 174,400 divided by negative 4. All right, so I'm going to put it in my calculator just like I did before. So when I use the subtraction sign, so negative 920 minus second square root 174 400 equals, divided by -4 equals. So one of them is $334. Let's see what it is when I use the plus sign. Divided by -4 is $125. So over here, if I charge too little, that would be, if I charge $125 for my product, I won't make any money. And over here, if I charge $334, then I will have charged too much money. So, thank you.